Hi and welcome to my video on adding and subtracting fractions. Hope you enjoy it. Now then, let's look at fractions to start with. Here we have a typical fraction, 3 over 7 or 3 sevenths. What I've done here is actually show you a pictorial view if you like. So we're actually looking at 3 parts, 1, 2, 3, shaded in yellow, of 7. So 3 parts of 7 squares, and that's all a fraction is. Now, we do have names for both these parts of the fraction. You do need to remember these. So the top number is called the numerator, whereas the bottom number is called the denominator. So numerator, top number, denominator, the bottom number, you need to remember them. Now, this is a typical type of fraction where the numerator is smaller than the denominator. That means it is actually less than 1. So whenever you have the numerator smaller than the denominator, it is a fraction that is less than 1, and we call that type of fraction a proper fraction. Okay, a proper fraction. Now, during your course, you will come across fractions where the numerator, so this is no longer applicable, the numerator is bigger than the denominator, in which case that will be a value greater than 1, and in most instances you were then expected to change it to a mixed number, which means in this case 3 would go into 7 2 times, so it would be 2 whole, and it would be 1 left over because 6 away from 7 is 1, so 1/3, so it would be 2 and 1/3. Now that type of fraction, some people call the top heavy fraction, the proper name for it is an improper fraction. So you have a proper fraction less than 1, numerator smaller than the denominator. When the numerator is bigger than the denominator, be careful, it is an improper fraction. In most instances, you will be expected to change it to a mixed number. Okay, let's look about adding fractions. I'm going to do a really easy one here. We've got 3 over 7 added 2 over 7. Now I've shown here, just so we can view it, 3 lots of 7 plus 2 lots of 7, and that surely comes to 5 over 7, 5 lots of 7. Now 5 over 7, not 5 over 14 as some people mistakenly put. And I hope by looking at this bottom picture here you can see why, because you're talking of 3 lots of 7 plus 2 lots of 7, 5 lots of 7. So when the denominator is exactly the same, it stays the same on your answer, and you're just looking at how many parts you're adding together, and it's straightforward. Now unfortunately on the exams that's not always the case. So we've got a sample here, 4/11 plus 1/3, or 4 over 11 plus 1 over 3. And first thing we're going to do is we're going to do equivalent to, so this sign means equivalent to. We're going to write the fraction out again with what we call equivalent fractions. Just talk to you a little bit about the equivalent fractions. If we look down here, we have a fraction which is 1 part out of 2. The yellow part is 1 out of 2, which is obviously a half. If I take this line here and we split it in the middle, well, now we've got 2 parts out of 4. So, and nothing's changed, it's still the same size. So 2 over 4 is the same as 1 over 2, or 2/4 is the same as a half. Just give you that, explain what equivalent fraction actually is. Now, so we want this to be an equivalent fraction over here and added to an equivalent fraction here. And what we want to do is have the equivalent fractions here with the same denominator. If we can have the same denominator, it'll make it very straightforward to add the top two numbers within 2 numerators together and give us the answer. So first of all, when you get something like this, what I would do is see if the smaller number will go in the top number. If the smaller number goes in the bigger number, then you'll find you can use a bigger number. Unfortunately, in this case, 3 doesn't go into 11, so we can't. So we need to think of a number that both 3 and 11 will go into. Now, the easiest way to do this is multiply them across. So 11 times 3, or as we said earlier, order doesn't matter. When you're multiplying, 3 times 11 is 33. So if we make that 33, and this one 33, we can put these both here as 33 as the denominator on both fractions. So we know 11 goes into 33, and we know 3 goes into 33. Now we're going to look at the top number. We want this as an equivalent here as over 33. Then we multiplied 11 by 3 to get 33. So we simply multiply the 4 by the 3 to give us 12, and we can put that straight up there. So 4 over 11 is equivalent to 12 over 33. If you draw it in pictorially, they would be exactly the same shaded areas of the same amount. So we're going to do the same on this side now. We want an equivalent fraction of 1/3 as over 33. Now we times the 3 by 11 to get 33. So we can simply multiply the numerator by 11, and it obviously gives us 11. So now, like we said earlier, we got the same denominator. We keep the same denominator. So we've got 12 parts of 33, add in 11 parts of 33. And that is just adding the top numbers, 12 and 11, 23, and that simply goes up there. Doesn't break down. Be careful to make sure, in case there's a number that could go in both of these and make it a smaller simplified version of that, but in this case it doesn't. So just a quick recap. We take two fractions, denominators are the same, are different. First, to see if the smaller number goes in the bigger number, in which case we can use the bigger number. If we don't, in this case they don't, we multiply the two bottom numbers together to give us two fractions which are equivalent, so the denominator is the same on both. Then we take the top numerator on the first one and we multiply it with the denominator on the second fraction, so the 4 multiplied by 3, and put it there. But then we take the numerator on the second fraction and we times it by the denominator on the first fraction, and that gives us 11. And we simply add in the 12 and 11 across. The denominator stays the same. Okay, straightforward, I'm sure you agree. A bit of practice and you'll get these really, really easily. Now, when we're subtracting, again, we've got 3 over 7, 3 parts of 7, take away 2 parts of 7. So 3 parts of 7, take away 2 parts of 7, leaves you 1 part of 7. And again, with the denominator, exactly the same, then that stays the same there, just as before. And it's fairly easy when the denominator is the same. But as in the first instance, we might think about what happens when the denominator is different. Well, we do exactly the same, but we've got to be a little bit more careful. And when we talk about subtraction, because I said in the previous video, order does matter in subtraction, so we have to be a bit careful. First of all, we're going to again multiply the two denominators together. So 11 times 3, 3 times 11 is our friend 33 as previously. So we've got 33. We are subtracting now, so we've got a subtraction sign there. Again, just as before, we made 11 to 33 by multiplying it by 3. So we do exactly the same with the top. So the 4 times the 3 is 12, as before. Now, same as before, we're going to start with this one, and this was, we multiplied the 3 by 11 to give us 33. So we now multiply the 1 by 11 to give us the 11. Now, we now got the fraction that has the same denominator, so the same denominator stays there. But now it's quite straightforward. It's 12 over 33, take away 11 parts of 33, so 12 minus 11 is just 1. And there's your answer, 1 over 33 or 1/33. Now be careful, when you do this you must start up there because order is important. If you start there, you would end up with 11 minus 12, and you have a minus 1 there, and you can't have that, it'd be wrong. So order is important, as I said in my earlier video. Be careful, always start on the left hand side and multiply them across. Okay, all you need to do is practice a few of them, and they're as straightforward as adding. So thank you very much for watching. Hope to see you soon.